Okay, looking at example 7 in the book, a division of Carter Enterprises produces personal income tax diaries. Each diary is selling for 8, and it has, of course, fixed monthly cost and variable cost. Okay, so looking at Part A. Part A asks us to find what is the break-even point for the division. Okay. Remember, what break-even, all it's about is when revenue equals costs. Okay, so let's go up there and get some information here. Our revenue is the amount of money we get from selling, and we sell them each diary for $8, so 8x. Now our cost is always a blend of two things. It's always the fixed cost and the variable cost. Well, the fixed cost is $25,000 for the company, and then the variable cost, they have to incur $3 on every item sold, on every diary sold specifically. Okay, so solving this out, if I move the 3 over, we get 5x to be 25,000, and dividing by 5 on both sides, then we get x to be 5,000. Okay, so basically, when that company, specifically the Carter Enterprises, makes 5,000 diaries, then we know that the profit equals 0. Okay, so let's write that out. So we can say profit equals $0 when 5,000 diaries are sold. Okay, helps if I write actually 5,000. Okay, so now, knowing this, let's go on to Part B. Part B says specifically is that we want to, what should be the level of sales in order for the division to realize a 15% profit over the costs of making the diaries. Okay, first of all, let's find our profit function. Remember, our profit is revenue minus costs. So it's going to be our money coming in, 8x, minus our cost, which is 25,000 plus 3x. So in an equation, then our profit is going to be 5x minus 25,000. Okay. All right, and so now what we want is we want this profit right here to be 15%, so 0.15 of the cost of making the diaries, specifically like when we break even. So let's find the cost basically of $5,000. So we're going to find 15% of then the cost of breaking even, which is when we make 5,000 diaries. So going up to our cost equation, and it's 25,000 plus 3 times the 5,000, because that's what we just discovered, that we break even specifically at 5,000, and we want to go 15% higher because we want to go into the profit. Okay, so if we look at this, 3 times 5,000 is 15,000 plus 25,000, so we're looking at 15% of $40,000. Just doing the math on that real quick, comes out to being $6,000. So we want to know a profit. When I go a profit of $6,000, what kind of sales do I need to make? So solving this out move the 25,000 over and divide by 5. We'll get an x value of 6,200. So we need to sell 6,200 diaries in order for a 15% profit. All right, let's go on to the next topic. In this lesson so far, we've been talking about linear equations and quadratic equations. We've really been focused more on the linear because we've been graphing the break-even point and looking for that. And the unique trait with the linear equation is they have a constant rate of change, meaning their slope is always the same, you know? It's always up 1, right 2, up 1, right 2, or down 3, left 2, or something like that, okay? Well, a special trait about the quadratic equation, which is that parabola, is the fact of we have a vertex. And what the vertex is either that lowest point right down there, or it's the highest point right up here, okay? And that's what the vertex is all about. And if it's the high point, it's called the maximum. If it's the lowest point, it's called the minimum. And that really works out a lot in the business world because they're always going to know, what do you have to do for the minimum value? What do you have to do to maximize profit or minimize cost? And so what we're going to be looking for are these high points and the low points. Okay, and if we go right down below here to the next bullets, it's saying in order for a quadratic equation, when it's in general form, Remember, general form is when you have each term going in descending order, and a is just like the quadratic equation. The a is always the number of the coefficients attached to x squared. The b is always attached to x, and c is your constant. Okay, how we're going to find that vertex is it's a coordinate, so the x value of that coordinate, you're going to go negative b over 2a. So the negative b over 2 times that leading coefficient. And then to get the y coordinate, we're just going to take this x value and plug it back into our equation. All right, so let's practice doing this. Here in example 8, just real quick, just check to make sure that in your function right there that you actually have it in descending order. Everything looks great, and does. So if we go up there, we know that a is 3, b is negative 5, and c is 1. Okay? We would use the quadratic equation if we wanted to find the x-intercepts, but in this case, all we're wanting to do, first of all, is find the vertex. Okay, so let's find the vertex. All right, the first thing is to get the x value of the vertex. It's the formula negative b over 2 times a. So it's going to be a negative 5 over 2 times 3. So it's 5 over 6. And there is the x value for the vertex. Now to get the y value, I'm going to go back up into the very main function and plug in my x value. So it's 3 times the 5, 6 squared minus 5 times 5, 6 plus 1. All right, this looks fun. So 3 times 25 over 36 minus 25 over 6 plus 1. Okay, so 75 over 36 minus, if I kind of try to get all this into the common denominator of 36. Okay, 1 is obviously 36 over 36. So for this middle fraction, I'm going to need to multiply the top and the bottom by 6. So 150. And then if we go 75 minus 150, so negative 75 plus 36, we'll get negative 39 over 36, which if we divide everything through by 3, then we'll get, at least shrink it down a little bit, negative 13 over 12. That was kind of gross, but there's the coordinate of our vertex right there. Okay. So the key is, I kind of picked a harder one to start with, sorry about that, but it's just to realize that whenever you want to find the x value of that vertex, just always do negative b over 2a from your quadratic. Okay, and then to get the y value, just take whatever you found there from the negative b over 2a part and plug it into your main equation. Simple as that. All right, so let me erase some of this work, and then let's go find our x-intercepts. And with our x-intercepts, we're going to use that other formula that we had to memorize. Okay, just remember x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Just remember, any of these formulas that we're using, y'all are going to be responsible to know for sure. So a negative 5 plus or minus the square root of negative 5 squared minus 4 times a times c all over 2a. Okay, so it's going to equal 5 plus or minus the square root of 25 minus 12 all over 6. So 5 plus or minus the square root, 25 minus 12 is 13 over 6. And you know, I'm probably going to leave it like that. So our two x-intercepts are 5. If I was going to actually graph, I would go through and plug this in my calculator and get the decimal out. But, you know, this is pretty good for right now. It's just one time we're going to write it as 5 plus the square root of 13 over 6, then comma 0. And then 5 minus the square root of 13 over 6, comma 0. So the whole goal with that was just to realize also with your quadratic, in order to find the x-intercepts, you use the quadratic equation. All right, let's go to example number 9. Again, with this one, we just want to get a little more practice finding the vertex. So let's go to this main function. Remember, f of x just stands for y. So this is y equals, and let's organize it. I have a negative x squared. I don't have an x term, and then I have my plus 5. So that really helps me out because a is negative 1, b is 0, and c is 5. So it's really good to be able to see those points. So let's go to the vertex. The vertex, the coordinate, the x value of that coordinate is always negative b over 2a. So it's going to be negative 0 over 2 times negative 1. Well, 0 on top of the fraction, no matter what, always gives you 0. Remember, 0 on the bottom is undefined, but 0 on the top is 0. So that was a lot easier. Now to get the y value, let's go back and plug it in. So negative 0 squared plus 0 times 0 plus 5. So that goes away, and we get a y value of 5. Not too bad. Let's go on to, let's see if it's easy to get our x-intercepts. Okay, so the x-intercepts, we're going to get x is equal to negative b, so negative 0, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So negative 0 out front is still just negative, is just 0, so I'm just going to go plus or minus the square root. 0 squared is nothing. And negative 4 times negative 1 is 4, times 5 is 20, all over negative 2. Okay, well I know that 20 right here is 4 times 5. The square root of 4 is 2. Square root of 5 can't quite do, so I got to leave that inside, and then over negative 2. Don't forget my plus or minus there. So when if I divide this through, then it's basically going to be plus or minus the square root of 5. Because with this negative down here in the denominator, if I go with the positive 2 square roots of 5 over 2, then it would be just, yeah, let me write it like this so y'all can actually see it. Now I'm talking out loud. Let me go and write it like this. So y'all can agree with me and you're like, what is she talking about? Alright, so if I have 2 square roots of 5 over negative 2, or negative 2 square roots of 5 over negative 2, if I go through and actually reduce this out, you know, that goes into that, leaving me the negative square root of 5 comma 0. And then negative into negative would be positive, so then it would be the positive square root of 5 comma 0. And there's my 2 x-intercepts. Alright, let's almost finished here with this lesson. Let's just keep on going to example number 10.